Number 37, find all of the ways in which 200 can be written in the form 200 equals p equals the sum of p and q squared and r cubed, where p, q, r are prime numbers. Okay, so have you noticed that the sum of them is 200, which is even, right? So it means P, Q, R cannot all be odd. They can also not can just one of them be odd. So since now 37, find all the ways in which 200 can be written in the form 200 equals the sum of p plus q squared plus r cubed, where p, q, r are prime numbers. All right, so have you noticed that the sum of them is 200, which is even? So it means that p, q, r cannot all be odd, nor just one of them be odd. Okay? So let's verify it. If all of these three are odd number, odd plus odd 3, then we may get an odd number as well, which is not 200. So these three cannot all be odd. Okay? And if just one of them is odd, the other two are even, then we may also get an odd number, which is definitely cannot be 200 as well. All right, so PQR cannot all be odd, nor just one of them be odd. But can all of them be even? Because even plus even is also even. All right, so if all of them are even numbers, and also they are also all of them are prime numbers, the only even prime number is 2, then we may have p plus q squared plus r cubed equals 2 plus 2 squared plus 2 cubed, then we have 14, which is not 200. So this one is also, this is not possible. Okay, so let's continue. So it shows that two of P, Q, R must be odd. And the third one must be 2. All right, so we have odd plus even, which is 2, all right, equals 200. Okay. Therefore, we can verify it one by one. To reduce the possibilities, it is best to start with the cube term. So because 7 cubed is more than 200. So the possibilities for R is 2 or 3 or 5, because 4 is not prime, right? So the possibility for R is 2 or 3 or 5. So let's just verify it one by one. Okay, if R is 5, then we may have 5 5 square is 125. Then we have P plus Q square equals 75. All right, so if P is 2, then Q square is 73, which is not a square number. Okay, but if Q is 2, then Q square is 4, then P is 71, which is a prime number. So this one is possible. We have one possibility that Q is 2, P is 71, and R is 5. All right? And let's further work on R. So when R is 3, then P plus Q square plus 27 equals 200. Therefore, P plus Q square equals 173. And in this way, if P is 2, then Q square is 171, which is not square. And if Q is 2, then P equals 169. But 169 is not a prime because it can represented as 13 times 13, which is not a prime. So both of them are not correct. All right? And let's further work on it. When R is 2, then P plus Q square equals 192. In this case, 192 is less than 196, which is 14 square. All right, so in this way, Q is an odd prime number less than 14. So firstly, we can work down from Q is 13. Then Q square is 169. Then P is 192. It's a difference of 192 minus 169, which is 23, which is a prime number. Okay, so let's do further work on it. When Q is 11, then Q square is 121. P equals the difference of 192 minus 121 equals 71, which is also a prime number. And when Q, let's just further work on it. When Q is 7, then Q square is 49. Then P equals 192. Equals the difference of 192 minus 49 equals 143, which is not a prime number because it can expressed as 11 times 13. Okay, so when Q equals 5, then Q square is 25. Then P is the difference of 192 and 25, which is 167, which is prime. All right. And finally, when Q is 3, when Q is 3, then Q square is 9. P equals 192. The difference of 192 and 9. And then we get 183, which is divisible by 3. All right, because it can express as 3 times 61, okay, which is not prime. Therefore, have you noticed these 4 possible answers? So these 4 answers are possible, which can make a final answer here. Therefore, there are 4 possible triples for PQR, and they are 71, Q is 2, and R is 5. Okay, and the next one, P is 23, Q is 13, and R is 2. Okay, and next one, P is 71, Q is 11, and R is 2. And the last one, P is 167, Q is 5, and R is 2. All right, so there's the answer of this question. Okay.